Okay, so based on the similar example here, so on the previous video, we already show it using the spherical coordinate where the answer of the volume of the solid is 5 pi over 12, but it looks a bit messy because you have to split the solid into two. So now we want to look at how about if we solve using cylindrical coordinate, whether it is possible or not. Okay, so now based on the similar solid that we have sketched before this, okay, you have the combination of the surface. I mean, this one is a sphere, the standard sphere centered at the origin, and radius 1, and the other sphere is shifted about one unit along the z-axis. Okay, so we have this particular solid. So but then we want to solve using cylindrical coordinate. So for cylindrical coordinate, we need to get the limit of theta, the limit of r, and the limit of z. Okay, so for the theta, so the theta is the same as in spherical coordinate where we have to look at from the region. So from my previous explanation, I already show you how can we got z equal to half, right? And then when we plug in z equal to half into one of the equation here, and we will get a circle with radius 3 over 2. Okay, so then we can see that it is a complete circle. So now we can see directly the limit of theta is 0 to 2 pi, and the limit of r from 0 to 3 over 2. So we can get the limit straight away from the region for theta and r. How about the z? Okay, for the z, it is you have to be careful. So now you yourself is lying inside this solid, and you can see that your lower bound is from the shifted sphere, while your upper bound is from this particular sphere. Okay, so you can see that then you can write down your z. Okay, so but then because you cannot z directly, you cannot z equal to directly from this equation, from these two equations. So meaning that you have to rewrite this equation to be your upper bound. You have to find the z equal to, because you want to get the limit of z, right? So you have to rearrange this one to be z equal to, and similarly for this one you have to find the z equal to. So what I'm done here is I try to rewrite the lower bound in terms of r, because in cylindrical, z is okay, z is z, and then x and y you have to convert into r and theta. So we know that from polar, this one is equal to r squared, and now I'm trying to rearrange and just obtain the only z on the left side. So okay, this one you have to be careful. So when you have z minus 1 squared equal to 1 minus r squared, and you have to do the square root, then you have to consider whether it is positive or negative. Okay, so positive or negative. So you cannot have at the same time. You have to choose either one. So in order for you to determine whether it is positive or it is negative, then you have to look at again carefully your solid here. Okay, your solid here. So how can you have this solid? So from our discussion on the previous video, so it looks like this solid is a combination of the sphere shifted 1 unit along z, and the standard sphere centered at the origin. Okay, so now your vision on the zy plane. So I try to redraw here because I want to find out the possible lower bound equation. So for the upper bound, which is this one, you have no problem because you can see that this one is coming from the standard sphere, where the z here is positive because it is the upper part. Okay, the upper part, because z negative down here. So when you do that, okay, from this equation, from this equation, you have to find the z, right? But the z should be positive square root, where this is your upper bound. Clearly seen because the z for this red line is positive area of the z. So you just choose positive square root. But how about your lower bound? How can you get this lower bound? So your lower bound here is coming from the circle or the sphere shifted 1 unit above along the z. So meaning that this one is the curve of the z when z is negative, because it is shifted, right? So so this is the borderline because it is shifted. So this is the borderline. So the top one is for positive z and down here is for negative z. So in order for you to find out the z from this equation, so you have to consider the negative. So you have to consider, so this one should be negative. Okay, not positive. If you put positive, it is wrong. Because the z for the lower bound is only for negative value of z for this particular sphere or circle on ZY plane. Okay. And then now we obtain that the upper bound, so the lower bound is part of the shifted sphere where given by the z equal to 1 minus square root. Okay, this one. This one. And the top or the upper bound is given by the standard sphere where z is always positive because of the curve lying on the z positive. Alright. So next, what we can say that now we obtain the limit of z and the limit of r and theta, and then we put into the formula of the volume using cylindrical coordinate. And when you evaluate this, so please again evaluate yourself. So this one should be negative. Okay, that one should be negative, and you will obtain this value where the answer is the same as you done using spherical coordinate. And you can see that using the cylindrical is more easier, but you have to be careful in choosing the correct z, whether it is positive square root or negative square root. You have to be careful. Okay, so if you don't, maybe for the first time you've seen this video, you're still confused, but you have to watch again and again. But if you're still confused, and then please consult with me. Okay.